Ever wondered what mysterious force keeps the planets neatly circling the sun, or why an apple doesn't just hang in the air but falls straight to the ground? Welcome to the intriguing world of Newton's law of universal gravitation. This law, proposed by Sir Isaac Newton, states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simple terms, the bigger and closer the objects are, the stronger the gravitational pull between them. The mathematical formula that describes this law is quite straightforward. The gravitational force, F, equals the gravitational constant, g times the product of the two masses, m1 and m2, divided by the square of the distance, r, between their centers. The gravitational constant, denoted by g, is approximately equal to 6.67430 times 10 to the negative 11th power cubic meters per kilogram per second squared. Gravitational force is all around us. It's what keeps the moon orbiting the Earth. It's why an apple falls from a tree to the ground. It's the reason planets maintain their orbits around the sun. This law doesn't just explain these everyday phenomena. It also has many practical applications. It's used to calculate the motion of planets around the sun. It explains the rise and fall of the tides. It predicts the behavior of falling objects. It even guides the design of rockets and satellites. However, Newton's law of universal gravitation isn't all-powerful. It works well for objects that aren't moving very fast or aren't too massive. But when dealing with objects that are incredibly massive, like black holes, or moving at near light speed, the law falls short. In these cases, we have to turn to Einstein's theory of general relativity to accurately describe the behavior of gravity. In summary, Newton's law of universal gravitation is a fundamental concept in physics that describes the gravitational forces between objects. It's straightforward, practical, and powerful, but not without its limitations. So, the next time an apple falls from a tree, you'll know exactly why it's heading straight for the ground.